So they're like really fresh on doing this, and they need help. So a couple buddies of mine were doing it, and they have no idea.
I'm like, that's
like,
don't get your haircut that often.
Brand new people, so we're
Just
like destroying them, and then we don't have to do a whole lot or as much as else.
Okay. I remember two of you were studying Latin before. So it will be your day. You have like 3 slides and like prepared. Maybe you can teach the class some notes. Like perhaps to please move forward, discuss something like this. Well, thank you for making your votes on Monday. I hope that you will not regret. It is a lot of work to do the project. So, on coming Friday, it is expected that completed with report on the research project. This is a lot. This is unbelievable and almost impossible. It's just hoping for a good luck. So tonight we will complete everything, and during Thursday we will write for the report. So it's the only comforting news that it is in some sort of replacement of an exam. If by some reason your Friday is busy, send your work to me. So today we will go over. There will be no actual class particular because it's you all are signed up. So complicated or taking time. So I'm going to provide some suggestions, guidelines, which make you maybe a little more comfortable or less surprises, less annoying, but just make it more strict. So first, I will cover what is expected to be in the written report. But the written report has no sense without completed research. It just it looks, from my point of view, it's better to describe how the final product looks like, and then in the second part of the meeting I will cover what is in how to arrange your research effort this time. So we are not the first people in the human history who are writing written reports. We're not the first people who speak publicly, or the first people who write for really bad public. And this idea was attracting attention of people for years, several thousand years before our age, 17 BC. And there were 2 schools. The Greek school covered just general principles of concepts and content, but I will not focus much. It is not very helpful. It's just a reflection of what is going on. The only important thing, conventions how you just design your thing. Then what is most important in reading reports is disposition. Alright. And in the ancient way, the goal of any public speech or written book has 3 thrusts. Anyone reads Latin, it will be not try it out.
You want me to read that?
Yeah.
Delectare docere volere
Okay, thank you. So, and the translation is on the translation is in the word. So, if you speak or write, it means that you want to urge to move your audience to do something. In the research community, if you write a paper, you want to, of course, help other researchers to know something new and apply it to useful things. But more locally, you want to convince reviewers that it is good enough to be published. You may think that by writing your exams in other class, you want to convince instructor to give you highest grade. That's a big thing. So the writings always has an addressee. You're writing to someone. Another thing is when it's to quiz, with some jokes in your writing. I don't know if you do jokes in your written post, but according to ancient thinkers, it is the right thing. And then to give something new. So Sasha is champion of public speeches, and he left notes how to organize anything in your life. He was so good that you can use some parts of his recommendations for your written reporting process. Because very soon I want to concluded interesting pieces of data, research, and equations, figures, tables. It's possible. But then how to put it together and how to write down. If you just put figures, that's it. It is not possible. It should be a document that a reader can understand without seeing this class. The outside reader should be okay. So the according to these ancient thinkers, there should be 6 sections, and if you're doing short report, it may be like 6 paragraphs. So the first one, yeah, I'm so happy that reads and read my first one.
Exciting.
Okay, so it should give just an idea of why the subject is interesting and why the audience will benefit from listening, or why the reader shouldn't close the book and select another one.
Narratio.
Okay, so this is where you just in longer reports, in true papers, you explain what other people who were focusing on the same problem did before you. Of course, in our timeline, there will be not much time to do it, but in true papers, you just cite 100 other papers, or at least 20 papers. This person does this problem is known, and is a partial progress. So you just overview what others have done. But our things, our case, we can just look into Wikipedia and give some general context. It should be there.
Particular.
Okay, so it's same like partition, splitting. In in here, there is a difference between modern research papers and ancient organization of speeches. Here, it is suggested that one just organize things before going to actual arguments and preparing reader listener to how things will be organized. In some sense, it is related to methods section in scientific papers, where you show main equations on which your approach is based. It's not one-to-one corresponding, but okay.
confident enough.
Okay, so here it is where the main idea or proof, main idea has been already presented by this time, when proofs and arguments in support of main idea are provided. So I will touch it again in about 5 minutes. At the beginning, you may pretend that you do not know the answer in your research and express it as a hypothesis, and then you organize your writing as proofs, as arguments to support your original idea. And this is what is interestingly in today's research papers, the section of results take like 60%, and the rest needs it, how to do it, the conclusion. So everything takes much less. In the ancient recommendations, the actual material will be like 10%, and the rest is just the heuristics explaining who and why need different. Okay. So, what does it mean? How do you translate it? I think it is not exactly what
Well, it comes from what has the same root as confrontation.
Okay. So I like it very much, and from ancient recommendations, it differs from what people write in scientific papers and written reports. Today there is a discussion session, but typically it is like toothless, very gentle. Here it recommends to, it suggests that there will be some level of, I wouldn't say aggression, but some confrontation. So the reader or reviewer or listener of whatever you give sometimes maybe not quite believing in your results, as you may have observed on the presentations when there were external guests. Right? You saw it. There were some questions that you were not expecting, putting in doubt your subject. One can think ahead of such situation and prepare, like set up your mind, who can oppose my results and how I will defend that the things I did are correct. And yeah, just yeah. And
Heterovacuum.
so which corresponds to modern conclusions when you summarize what you did, and here it's taken from this Wikipedia. You can find it. It tells like blame anyone who disagrees with your results. I don't know how to put it in a polite scientific language, but it is what Sisson suggests. And then arouse sympathy for the author. Well, I'm not saying that you should literally do it, but those are some ideas from 7,000 years ago. Right? Some today's papers do have a little simplified structure, more simplified structure. And I'm reminding you and to myself, group and bring 3 parts. Right. So in the introduction, you may tell why. I'm trying to squeeze and summarize main things. And, it will be there are no strict rules, but it will be beneficial if you try to do something along these lines. So in the introduction, you explain why a system is interesting. Identify open problem in your chosen area of research or pretend you are identifying it. So which question for each research activity there should be some part of knowledge that is not knowing before you start doing it, and that will become very up to you. But you may write down your vision of this. And the following thing is a little tricky. It is not always truly truth, but it is not right. So when you write your report, you typically know all the answers. You already completed your research. But for reader, it should be a little intriguing, same as if you are writing a detective story. There should be some intrigue that the reader wants to keep uncovered, and it will urge the reader to go forward. So you may tell that there is a question and there is a hypothetical answer that just from common sense we guess could be right. You can put your actual answer here, but do not tell that it is ultimate truth. Tell me, okay, it may be right, may be wrong, and we need to prove it. And then you express belief that computational modeling might have hopefully. So each research paper, and I have forgotten to say what we are doing here in this activities with research and reports. We are mimicking real research lab. Because if any of you, well, you may decide to go to industry, educational activity, or in academic lab, because the only thing to do in research and papers, and they are going through reviewing processes. So we are doing numerous processes. And in this activity, the goal of methodology is to enable your readers, allow your readers to reproduce your results. Because some readers can be skeptical and doubt that results are correct, but you're providing enough details that a reader can do the same. On the other hand, we all are busy, there is no time and space. Your reports will be maybe 4 page, 1 to 10 pages, just main ideas that will be sufficient for reader to believe that you're doing the right things. What is typical is good equations, not quotes, copy paste pieces of the code, just summarize main most important parts in form of equations. I think some of you are already doing it for previous presentations on methodology. Now, for results and discussion, which were merged together, results and discussion. Basically, especially if you shorten the discussion, you just put figures and tables. When you're writing code, you can make a screenshot and it will be a figure. If you are reporting some data, you can arrange them into a table, it will be a table. You put it, and then you go over and explain them what can you see and what you learn from one figure to another figure, and maybe share your vision by results. Then in the conclusions, you pretend that, oh, how nice, the results I have seen in these figures exactly confirm the original hypothesis. It is a great breakthrough. Let's celebrate it. So, explain the results support hypothetical answer. Then it will be like a detective story. And you may share your ideas if you believe that your results are everyone should trust them, that they are valuable for their benefits for the society. If you have some doubts in the results, it's not wrong to tell them. So these results are great, but because done with approximations and they can be improved. It's a very healthy approach. Any questions about written reports?
You said we're working on them tonight.
you're working on the results on the figures and tables tonight, and I don't know when you're working on reports, but on Friday morning you will be. So benefits for the society, the community. If the writing will be too technical, just showing some figures, no one except attendees of this class will be able to read it. But each, at least introduction and conclusion should be a little more general. And anything that researchers are doing have direct or indirect goal of making some good to community, to society. Maybe it is not direct, but you may think on the background how the project that you're doing helped society. And here are just some typical suggestions and guidelines. I apologize for showing some very naive thoughts, but it may just spark your thinking and if you gain maybe one more sentence in your report. So if you are doing research, you do publication studies that maybe into industry and research development for reading scientific papers and trying to optimize industrial processes. And then there are some solar panels or reactors, there are some cell phones because they include a lot of discoveries and technologies. And then they are directly going to users. And users support feds with taxes and feds support research. And there are some indirect influence because the process we are involved in result in training people to label the working industry and then see the same connection to exports for consumers of whatever is done discovered. And there is an additional pathway so that if anyone from whatever activity goes to education, then it also affects the community. So I will just mention so if you're, for example, the project by Kevin, which is listening. For example, your project, the interface between perovskite and titanium dioxide has an immediate application to energy conversion. So I just like this slide. It's not very applicable here. Just giving you heads up on anything you write will be opposed by someone at one day. Okay, so we are done with written reports and now some guidelines for actual research. So we were just relaxing. Okay, this morning you're relaxing, accumulate your strengths because this evening will be rural concentration, one of the hardest, most intensive things. So here are the list of possible figures. Again, the research is very creative activity. There are no strict guidelines, and it doesn't mean that if you do one less or one more, anyone will be punished. When the projects are very individual, very specific, with just general idea which figures you can make as a snapshots and insert in your reports. So one can make a schematic diagram of what you are exploring without detailed curves, without if it is photovoltaics, you can draw sun, a ray that comes to a device, and then the electricity goes from power plant, something like this. Again, no requirements, just possibility. Any research that we are doing, all research activities do include propagation of wave packet in one or another potential. Right? So if you are telling your story to a reader, you may want to introduce your potential. And then in text you will explain what does it mean. We were covering it in the labs that one can find eigenenergies and eigenvalues for this potential. Right? And one can plot them offsetting the functions by eigenenergy. This is maybe for some projects it is optional, but for some it will be really helpful because later on you introduce your Gaussian or non-Gaussian wave packet, and you can tell immediately that shape of the wave packet is so much different from the eigenstate. There is no doubt that it will move in space. Because if you start from eigenstate, there will be examples of typical dynamics. Remember, when you are running the MATLAB scripts, there is a popping up a huge amount of maybe unnecessary panels with old data. And one of the panels is like a three-dimensional colorful figure, where one axis is position, another time, and another is probability density. So this is very visually appealing, and if you do this three-dimensional distribution of probability as a standalone figure, it can help reader to understand what you're doing. And it is rather general. I think this figure can be included in any in about half of a project, one can split your space, your area of physical area, coordinate space, onto space corresponding to reactant and product, and one can make integration over reactant and product. And population of reactant and product as function of time is especially relevant to those who are doing projects related to chemical reactions. It is also rather general population of probability of product and reactant change with time. If they change quicker, it is efficient reaction. If it goes fast, doesn't change in time, it is not efficient. The slope of this change of the product probability is a rate of reaction. I will cover it in a little more details tonight. I hope there will be 2 minutes for it. And this rate of transmission, the rate of reaction, depends on some initial parameters, and it can be recorded and plotted. This is really interesting and strong thing, and for a couple of projects, it will be the main result, dependent on the rate of reaction on initial temperature or initial momentum. And when temperature and momentum are corresponding to each other, so I can put it as function of temperature and use values more to extract activation energy. So this is like ideal schematic. Do not, if you feel it is too much, do not panic. Again, research is very creative. Whenever you may set up different goals, it is just general lines. So this year, your choices of classes this year were much more diverse than previous years, which is really good to see. It shows that there is a creative thinking in different directions. So it's great for one. For another one, it is a little more complicated because they are so independent and so different. In previous years, almost every project was on reaction rate, and we all were doing the same protocol. Right now, there is a little additional diversity. But the generalizing common pattern for all projects is as follows. in all projects, you can identify your main observable, and you can identify a parameter that you're looking. So in some sense, the big scientific problem can be reduced to just one-dimensional curve, where on X you have a parameter, on Y you have the main observable. And then any project can be formulated as response of main observable to change of a parameter. My favorite and easiest example is when the parameter is temperature, main observable is rate of reaction. And then your research protocol, you change from the parameter, run the code, report value observable, and then report observable as function parameter, which was suggested as figure number 6 in the previous slide. But some of your chosen research directions have a rather exotic parameters and observables. You will be able to identify them. And you have to do it. So, parameter can be temperature, momentum, frequency of incident height, magnetic field, or maybe something more exotic. Examples of observable rate of conversion from product to product, amplitude of oscillations, energy of observed between specific states. So, in the remaining time, I want to do two things. First, I'm going to bring in the list of projects and share some quick, my personal opinions of what could be the parameters. Again, it's your independent creative activity, but maybe the suggestions will help. And then the remaining part, I will go over of the research steps, research protocols that I was already showing before, like steps to complete. So here's the list, and I will, don't forget, Friday with facts. Pink is classical, typical, standard, canonical projects where your parameter is momentum, corresponding to energy, temperature, and your observable is rate of reaction. So you do different values of each which rerun your code with different values before makes before the rate of developing a product entropy. So about 5. 1, 2, 3, 4, 5, 5. Those are easy steps. So the yellowish color related to those who are special. Again, it was the choices, and the parameter that needs to be scanned is different. So for Joseph, he tends to be a chemist, it would be scan voltage. For I will talk about the project by Alex. It is very special. It doesn't go into like standard protocols. For given, you just scan frequency of incident laser. You try to apply external field of different frequency, and you see which one will provide quicker accumulation of energy. The project by Isaiah, in his project, the external laser field quickly converts electronic state from ground to excited and back, and he will change how quickly it happens. Mike. Fractional values of angular momentum, right? So you can
put in doubts discovery of Bohr and assume that angular momentum can take fractional values, not discrete, and see response of I don't know, energy, shape of orbitals, radius, energy on this, whatever you decide, and then show why integer values will be good and non-integer will fail. Gauge. Magnetic field is a parameter, and if one adds term of angular momentum times magnetic field into Hamiltonian, then one would expect that energy levels will split. The larger magnetic field, the bigger the splitting. But it's what books tell. But whether you will be able to reproduce, prove it right or wrong, it's the research. If this is too simple, there is a pulse excitation of doublet for nuclear magnetic resonance. It will be special for you.
I thought we established that one was way too hard.
Huh?
I thought we established that top one was way too hard.
This one too hard?
Yeah.
I agree. It was a research project for advanced quantum theory for graduate students. Well, I just applaud you how brave you are just mentioning this opportunity, but yes, this will be a little easier and quicker to handle. So, Alex has forking point. If he doesn't care about research and his growth as a potential researcher, he can just run it once and see how nice the results are. But because there are not much, you can change initial momentum, initial velocity, offset of these two wave packets, but it will be the same result. Most important is be analytical and explain how to create the states, not when you model and set up it initially as two Gaussians, but which physical principle will create such state. And the hint is when you take the same code as Ben for Marcus theory, it does create this superposition of states. So you may look at another code and see if your initial state will come out from another code. So it's less doing, more thinking. Maybe more writing. So pink and yellow, right? Different ways. And for those who was lucky to choose momentum as parameter and rate of reaction, the whole research project can be placed in the flowchart diagram. So you select model. Typically, each model has a barrier, right? It's like some shape of potential. And you can identify height of a barrier between the reactant and product. So you can just write down this number. And then on another hand, you select different values of initial momentum, which corresponds to if you increase temperature, momentum also increases. And it is, of course, we are skipping average over ensemble. But it is an approximation, otherwise we will not be able to finish quickly. Run dynamics, compute rate as function of momentum, convert momentum into energy and temperature, put this, repeat it several times, put data into Arrhenius, which gives a way how to extract activation energy based on set of rates and set of temperatures. And then compare those two numbers and tell if they agree or disagree. This is strong, interesting, and even potentially publishable. I do have flowcharts for those who are not in the energy, momentum, and rates, but one can think of similar arrangements. Okay, I'm almost done, and here is the list of steps that you have already seen. It's rather long and boring, and just show it once again. Select potential, still activation barrier, initial So select where you start, where you wait packet. The variables for probability in the reactant and product are already available there, but you can tune them because the point in space that separates donor from acceptor is different, can be different in each product. And as soon as you find probability of reactant formation as function of time, you can convert it into the rate in two ways, either by derivative, which you have a lot of noise, or just by feeding this curve into exponential. Repeat. Some of you will have doubts in which range to change momentum, because energy and temperature is core of momentum. So they are. It would be reasonable to select them in the range from 0 to 2 activation energies. However, the values won't be exactly equal. And again, it is for those who were painted with pink. If you are changing momentum, thinking of it as a prerequisite for temperature and different rates, just record values of momentum, record value of kinetic energy, which is square of momentum, and you can add another column with converting to temperature. Yield of reaction is population is amount of product at last time, and then rate of reaction to a different formula. So this data can be fit into rate as function of temperature. And then at different comparison between your kinetic energy and activation energy, there will be qualitatively different behavior of reaction. You all will observe it if you haven't observed it before. Analyze. Will the wave packet ever return to initial state? You may share your opinions. I'm not going to answer because what are you doing? When you're writing reports, it's a healthy. It's not like super mandatory, but it's very healthy thing to list approximations. What is neglected? There are no absolutely exact calculations at all. It's always something that is approximated and neglected. A good method, an improved method, it's going to conclude. And this will be for the next week. Next week you will create movies and include them into presentations. Thank you for your patience. Accumulate energy for a great breakthrough session tonight. See you at 5. Special thanks to Ben for pronouncing inviting. On Friday, print 3 copies. Yes.
Planning and
I have a question.
The data he provided, you have offset energy of the acceptor, which was so set it to like 1/10 of it can justify it. Then you write much better. Yes.
So as I was glancing through the article you sent me, I could not figure out what you meant by cap. Yeah, I'm gonna read it again before I come tonight and see if I can glance through it.
Which article
You sent me one.
link to Wikipedia article?
No, it was a scientific article.
Authored by who?
I don't remember.
If it was hosted by myself, it probably is very boring and not interesting. It probably would be first.
On cat state and cat
Cat state or choosing a cat state or superposition state of parameter state. It's very, very popular. It's papers in the subject are cited like 1,000 times, and they're used for quantum information processing for secure information for quantum computers. And, there are several implementations of this idea in either vibrations of ultraviolet ions in the traps, or the electromagnetic field is also sort of harmonic oscillators in fiber objects. So there are like several implementations.
Alright, so I'll look for cat state on Wikipedia and I should be able to figure it out. Got it. See you tonight.
So for my project, you sent out an email last week with different wave packets.
Mm-hmm.
Do I just use one of those wave packets that you recommended for my project then, or which wave packet am I using?
Which potential? We need potential.
That too, yeah.
Okay. Did Braden send anything to you or not yet?
He didn't send me any potentials or anything.
Because he computed them, sent them to me for an approval, and then it looked like he did something not wrong, but very opposite to my opinion, and therefore he is probably hesitant to share. But I will visit with him today, and you will have some potentials before that.
Okay. Because he and I, when we talked, one of the things that Zach had a problem with was he had negative rates.
Mm-hmm.
And so Braden and I were talking, if we put wells in our wave function packet, whatever, we could possibly eliminate that.
So what was negative?
Zach's rate.